Good morning, everyone. In this lecture, we are discuss about incentive on power plant. In the previous lectures, we have already discussed about effective decision and other points. So, in this lecture, we will discuss about incentive on power plants. So, before going on this lecture, I would like to explain that what are the learning objective of this lecture. To introduce students to the basic theory of power generation process and to familiarize students to the incentive of power plants. So, course outcome of this power plant is that after this lecture, I'm expecting from students that student will be able to understand the incentive of power plant. These are the content: introduction, depreciation, and optimization. So, before going on this content, first we have to understand that what is power generation process. So power generation process means that the power which is generating, and the depreciation charges the equipment day by day, you know, getting getting old and their maintenance is required. So day by day their cost is reducing. That is your depreciation. So sum of depreciation charges is always added to the tariff, and tariff is the cost, electricity cost, which you are paying to the grid or to government. So, high norms for target availability possesses significant risk. Generating stations for non-recovery or fixed charges mitigate. Such risk following is proposed for kind consideration of the Commission. So cumulative availability for the total tariff period may be considered instead of the present practice of annual availability, so that non-recovery of fixed charges in any particular year can be compensated by improved availability in the subsequent years. So drawl schedules of the beneficiaries may be limited to generation corresponding to target availability, and generation beyond this may be allowed for trading direct power supply. So trading in availability may be considered a station which is unable to achieve target availability level can purchase capacity from other station to offset its deficit. So incentive or disincentive may be provided on equitable basis. So what is incentive on availability? The concept of availability based tariff as finished in the NTF provided for incentive on availability of the station. So this was uh, advised to incentives generators for making the units available to meet the requirement of the grid. So providing incentive based on availability will also ensure the actual generation of the station is not PLF driven, which was earlier the practice and had resulted in wide frequency variations. So at present, ICBs are giving schedules considering variable cost plus incentive, which is distorting merit order operations. So incentive on availability will promote merit order operation. So further, for declaring the availability of the station, generator has to make all arrangements for availability of fuel, equipments, manpower, etc. PLF from the station thereafter depends on the schedules given by the beneficiaries. So in view of the above under availability based tariff, incentive should be linked to the availability of the station and not on PLF. So these are the incentive and disincentive under different tariff provisions. So this is your demand, and on the y-axis you can see that these are the fixed charges, and another is your incentive. So single part that is your fixed charges which you have to pay, and these are depending on your incentive or disincentive under different provisions. There are some particular provisions by which you will get the incentive, or you have to pay some penalty also. There are many criteria or many different criteria by which you can decide that what are you going to do. So this is the graph which is showing your different tariff provision. The purple line that is showing that it is increasing with your demand PLF. So as demand PLF is increasing, your fixed charges and incentive is also increasing. And this is the graph by which you can understand that deemed PIF ability, and this is the uh, KPRO, and this is the graph which is increasing. This is your single part. Okay, so these are the different kind of your tariff, and this is also showing the fixed charges and incentive. There are three graphs. A third one is showing your NTF, and in the this graph there is a fifth graph which is adding CERC order. So this is all about your incentive and disincentive under depreciation part. So incentives which is available according to PLF, and PLF we have already discussed in our previous lectures. So the concept of ability-based tariffs as finalized in the NTF provided for incentive or availability of the station. So um, Non-renewable energy is the conventional fossil fuels such as coal, oil, and gas. These are the conventional method for last thousand years. We are using these fossil fuel to generate the electricity. But everyone know these are limited sources on the earth. One day it will deplete. One day coal will deplete. One day oil will deplete. One day gas will deplete. Okay. So these are your non-renewable energy sources. Now, next come to the what do you think non-renewable resources are, which is available in the market? So we break it down in two parts: non-renewable and another one is your resources. Okay. So first we will consider non-renewable resources. So a non-renewable resources is a natural resource that cannot be remade or regrown at a scale compared to its consumption. Okay. For example, if you are taking coal, so you can't it remade and you can't it regrown. Okay. So once you consume this coal, you can't regenerate or regrown this source of energy. So this is called your non-renewable resources. Okay. Now, next, nuclear energy. So in the previous lecture, we discussed about nuclear energy, how nuclear energy is used to generate electricity. So we were using uranium 235, and what we were doing to generate the electricity from uranium 235, we were taking some atoms, and the atoms collide with uranium 235, and it again generate some atoms, and it divided into some electrons. So this procedure is called fission. And uh, during this fission or this procedure, a large amount of energy was generating. That energy was using to heat up the water, and water was converting into the steam. Then that steam was going to the turbine blades. So when you throw this steam with the pressure on turbine blades start to get rotate, and the turbine is also connected to the generator. So what happened? When you throw the steam to the turbine blade, the turbine start to rotate. So the energy of steam is converted into the mechanical energy. Then this mechanical part, which is your turbine, is connected to the generator. When a turbine rotate, and at the same shaft, generator is also connected with the turbine. When a turbine rotate, then generator will also start to rotate, and this generator will change the mechanical energy into electrical energy. So you were getting the electrical energy from the uranium. So main source of electrical energy in nuclear fission is uranium. So uranium is also as a source which can, once it is used, you can't you can never generate it again, and it never will be grown. Okay. So we have taken two examples. One is your coal and another is your uranium. So both resources of uh, generating electricity cannot be grown and reused, right? Once it is gone, it is gone. Now, coal, petroleum, and gases. So, everyone knows the price of petrol is increasing day by day. So, everyone knows that the petrol is limited on the earth. Okay. So, coal, petroleum, and natural gas as considered non-renewable because they cannot be replenished in a short period of time. These are called fossil fuels. Okay. Now I hope
you are able to understand that what is your fossil fuel. So fossil fuel means that they cannot be reused, they cannot be regrown, they cannot be regenerated. Once it is consumed, it is consumed. Okay, so these are your non renewable energy sources: coal, petroleum, natural gas, etc. Now, first we'll talk about that how is coal made. So it would be better to understand that why coal is called your fossil fuel and why it is limited. Actually, uh, be, uh, before 300 million years ago, the dinosaur and many game plants died in swamps. Okay, then what happened? uh, you can see that this is your plant, they get dead, and these are your dead plants. When they dead plants uh, get into the earth, the dirt layer will start on dirt layer will started on dead plants. Okay, so over million of years the plants were buried under water and dirt. Okay, so millions of years they were into the earth, and there was some temperature and pressure. Okay, so that was this is the scenario that water 100 million years ago. What happened there? The plants, dead plants, due to pressure and due to temperature, converted into the coal, and heat and pressure turn dead plants into the coal. So you can see that these are the rocks and dirt. Okay, and the coal, due to earth temperature and pressure, the dead plants and some dinosaurs or some game plants died and converted into the coal. So it took millions of years to convert it in the coal. Okay, now how are oil and gas made? So you can see over here that 300 400 million years ago there are some water animals. Okay, so tiny sea plants and animals died in the water and were buried on the ocean floor. Over time, they were covered layers of slit, silt and sand. Okay, so you can see over here that the plant and animal which were dead before millions of years, they were covered by sand and silt. And you can see over here that 50 to 100 million years ago, there is ocean. So over millions of years, the remains were buried deeper and deeper. The heat and pressure turned them into the oil and gas. Okay, so today you are getting oil and gas deposits over here. So it converted into sand and silt rock. So today we drill down through layers of sand, silt, and rock to reach the rock formation that contain oil and gas deposits. So I think now you are easily able to understand that what is fossil fuel and how it was made. Okay, so it took millions of years to convert it that trees and some animals to convert it into the coal and oil and gases. So this procedure is very lengthy. It took 300 or millions of years. Okay, after that we are able to get the coal, oil and gas deposits. Okay, so these are the limited fuel. These are the limited fuel. These fuels are called fossil fuel. Okay, now we come to the next point. What was the difference between coal and oil and gas? So I think now you are able to easily understand. First difference is oil is always get you get in the solid form, and oil is always you get in the liquid form. When you pressurize the gas, it is also converted into the liquid form. So if now question rise up, if non-renewable energy sources are resource that cannot be remade at a scale comparable to its consumption, what are renewable resource? One day the coal will be finished, one day the petrol will be finished, one day the oil will be finished. Then how will you get the electrical energy? Totally world is dependent on electricity nowadays. Without electricity we are nothing, you are nothing. Okay, so once it finished, then what are the other sources by which we can get the electrical energy? So now we come to the point, renewable resources. Okay, so now we will discuss what are the renewable sources and why we need these kind of renewable sources. So renewable resources are natural resources that can be replenished in a short period of time. Okay, so solar, geothermal, wind, biomass, and water. For example, day by day you are getting sunlight. Okay, sunlight is a solar energy. Geothermal, we will discuss it later, but in brief I will tell you. Geothermal means the heat of your earth. You are using the heat of earth to generate the electricity. Wind, everyone knows. Okay, so wind energy, the energy of wind you are using to generate the electricity. Biomass, everyone knows biomass, for example, cow dung and the agriculture wastage, which is used to generate the electricity. And next, it comes to the water. Okay, so these are the renewable energy sources. Now, first we will discuss about solar energy. So, energy from the sun, the energy which you are getting from the sun is called your solar energy. Now, why is energy from the sun renewable? Okay, so renew plus available. Okay, re plus new plus able. It means it is it has capability to regenerate itself day by day. Okay, so this is called your renewable energy source. Next, we come to geothermal. Okay, energy from earth heat. So why is energy from the heat of the earth renewable? Because this is infinity. It will never end. The heat of earth will never end. In the later slide, I will discuss how the electricity is generated from the geothermal power plants. Okay. Now we next come to the biomass. So what is biomass? We have already discussed that energy from burning organic or living matters is your biomass energy. Okay. So you can see that these energy sources are also infinity. Trees, you can regrow the tree. Cow dung, it is also available every time. And third one is your agriculture waste. So these are your renewable energy sources. Now let's come to the next point, which is water or hydroelectric. So what is your hydroelectric uh, energy? Actually, I have already discussed in hydropower plant that the energy of water we are using to generate the electricity. In this procedure, there is no wastage of water. Okay, so we have already discussed about hydropower plants. Okay, so energy from the flow of water, the water which is running or flowing, its energy is used to generate the electricity by some procedure, the procedure which we have already discussed in the previous lectures. Okay, in detail. So Now we comes to the consumption method at international level, national level, and state level. So energy consumption, you can see over here, there are four columns. One is your sectors. Sectors, it may be your industry, it may be your transport, it may be your domestic, it may be your commercial, it may be your others. International level and national level. And this is your state level. So what is international level industry? The consumption of energy at international level is your 51.7%, and at national level it is your 29%, and state level this is your 25%. Okay. Now in transportation, the energy which is consumed in the transportation of mm, uh, energy which is consumed in the transportation of uh, international level, this is your 26.6%, and the energy which is using and the energy which is using at the national level, which is your 27%. Okay. At commercial level, this is 7.8%, national level it is 9%, and state level this is 17%. Others, international level is 0, national level is 5%, and state level is your 8.4%. So this is the sector-wise energy consumption pattern. Okay. So most of the energy consumption is in industry. Okay. After that, it is in transport. Third one is your domestic purpose. Then it is your commercial purpose. Then for your other purposes. So by this by these rows or data, we can easily compare the consumption of electrical energy. Now, global uses by the source. Now we come to the sources, and we have already discussed about the sources of energy, which may be your renewable energy sources, which may be your non-renewable energy sources. So what is happening in the non-renewable energy sources? It comes coal, natural gases, diesel, and petrol. In renewable and nuclear and hydro. In nuclear energy, renewable energy sources, uh, it is used solar power, and biogas, and some other sources which is comes into the renewable energy sources. So the maximum energy which is generating in India just because of your coal, which is 60.8%. Okay, you can see over here, which is 60.8%. After that, it comes to the natural gases. So from natural gases, you are generating 8.4%. Then from diesel, you are generating electrical energy, that is 0.4%. After that, it comes to the nuclear energy, which is your 21%, and hydro energy, which is your 15.3%. Then it is renewable energy sources, which is your 13%. Okay, so these are the sources which we are using to generate the energy or getting the energy. So maximum amount of energy we are getting from the coal, and minimum amount of the energy we are getting from the diesel. Okay, so this is the global scenario of energy which is used. Now we come to the advantages and disadvantages of energy sources. So what is energy sources? We have already discussed there are many kind of energy sources. It may be your fossil fuel, nuclear, solar, and again it can be divided into renewable or non-renewable energy sources. So let's come to the first is your fossil fuel. What are the advantages of fossil fuel? It provides a large amount of thermal energy per unit of mass. Okay, we have already discussed in the thermal power plant that uh, how it is generated the electrical energy, and how much fuel is required to generate the electrical energy from thermal power plant. Okay, so it is easy to get and easy to transport. It can be used to generate electrical energy and make products such as plastic. Okay, now next come to the disadvantages. One disadvantage is this is non-renewable energy sources. One day it will be finished. Net, next is your when this product is burned, there are n number of gases which is produced and which is very harmful for your atmosphere and human body. So burning coal releases substances that can cause acid precipitation. Next, it is risk of oil spills. Okay. Now we come to the next power plant, which is your nuclear power plant. So in nuclear power plant, very concentrated from form of energy, power plants do not produce smoke. Okay. Next, produce radioactive waste, which is very harmful for a human body. In fact, the waste of uranium is very, very dangerous to our atmosphere and human body. So it is a very complicated procedure to dispose it waste. Okay. So it produces radioactive waste and radioactive elements are non-renewable. Okay. Now we come to the next point, that is your solar power plant. So solar power plant, almost limitless source of energy, does not produce air pollution, which is the best part of your solar energy. Okay, so it is limitless source of energy. Every day you are easily get the solar energy to produce the electricity. Now it is very expensive to use for large scale energy production, only particular in sunny areas. Everyone knows that if you want to produce large scale of energy from solar, so you need continuous solar energy. But in some particular areas, solar energy is not continue. Okay, so this is the disadvantage of solar energy. Now, next we come to the water. So, water is a renewable energy source. It does not produce air pollution. We have already discussed in our previous lecture that how electricity is generated from the hydropower plants. Okay. Now, dams disrupt a river's ecosystem available only in areas that have rivers. Okay. So, everywhere you can't get the water. There are some particular areas where you can easily get the water, some hilly stations and some like in India, if you want if you check that there are south and eastern area where you can easily get the water resources. Okay, but in Rajasthan it is very difficult to get the water resources to generate the electricity. Okay, so most of the power plant in Rajasthan is thermal power plant, which is that only practicals in wind energy. So wind energy is a renewable energy source, relatively inexpensive to generate, does not produce air pollution. Okay, so only practical in windy areas. Practically, it is not possible to get wind over the all over the areas, because there is some particular speed after that you can generate the electricity of wind. Okay, so wind is a renewable energy sources, relatively inexpensive to generate electricity, does not produce any air pollution. Next is your only practical in windy areas. Next come to the geothermal power plant. So almost limitless source of energy, power plant require little land. So only practical areas near hot spots where you can use heat energy of the earth to generate the electricity. So the wastewater which is coming from the ground after getting it heat to generate the electricity, it can damage the soil. So this is the disadvantage of geothermal power plants. So basically these are your different kind of resources of energy by which you can get the electrical energy, or you can generate the energy. Okay, but there are some advantages and disadvantages of these sources of energy. Now next is your biomass, which is your renewable energy sources. And actually, if you want to generate a large amount of energy from biomass, it requires a large area for farming. Okay, and second thing, it produces smoke. Okay, so this is the advantage and disadvantage of biomass. Now we come to the solar energy sources. So what is solar energy sources? Modern residential solar power system use photovoltaic to collect the sun's energy. And photo means produced by light, and voltaic is electricity produced by a chemical reaction. Okay, so commercial residential PV modules. Actually, what is PV modules? I think I must explain to you. Uh, Actually, PV modules are made of semiconductor devices like PN diode. Okay, so PN junction. Okay, so these are connected in series or parallel to make a form of array. Okay, when sunlight get fall on these modules, it start to, due to thermal reaction, the free electron start to get out of its conduction layer. Okay, so free electrons start, if you apply any kind of if you complete any kind of circuit, then this free electrons start to flow, and flowing of electrons is your electricity. Okay, so you can say moving of electron is your current. So commercial residential PV modules range in power output from 10 watt to 300 watts in a direct current. It comes into the form of DC current. So a PV module must have an inverter, because in our house and most of the places we are using AC power. So the electricity, so you can say the output you are getting from solar energy, that is your DC output. Okay, so if you want to convert into the AC, then you have to take a inverter to convert this uh, electricity, or to make it useful. Okay, so it required inverters. Now this is the solar energy source. You can see over here that the sunlight is falling on your solar panel, which is your PV modules. Then electric current start to flow, which is your DC current, and there is a charger or a charge controller which control the battery system. This DC power is stored in the form of battery over here, and then it is passes to the inverter, which convert DC power into AC power. Now solar energy applications. So heating solar energy can be applied in many areas. Nowadays it is very popular. So number one, heating and cooling of residential buildings, you are using solar power plants. Solar, second is your solar water heating. Third is your solar drying of agriculture and animal products. Then salt production by evaporation of seawater. Then solar cookers, solar engines for water pumping, solar refrigeration, solar electric power generation, solar photovoltaic cells, which can be used for electricity, and solar furnaces. So these are the solar energy applications. Now, next we come to the wind energy sources. So wind energy is a free renewable resources. So no matter how much it is used today, because you are not paying money for to getting the wind. Okay. So there will still be the same supply in the future. Wind energy is also a source of clean, non-polluting electricity. Unlike conventional power plants, wind power emit no air pollution or greenhouse effect. Right. So it is a clean fuel resource. Wind energy does not pollute the air like power plants, for example, thermal power plants. So, like thermal power plants that rely on combustion of fossil fuel, such as coal or natural gases, which emit particulate matter, nitrogen dioxide, and sulfur dioxide, causing human health problems and economic damages gases. Okay. Now, this is your the layout of your wind power plant that you can see over here. And a particular you are if you get the wind at a particular speed, it will start to rotate. These plates start to rotate, and when it start to rotate, it is connected to the generator. When it rotates, generator also rotate, and it will convert wind energy into the electrical energy. Now, next point is your geothermal energy sources. So geothermal energy is heat from within the earth. We can recover this heat as steam or hot water and use it to heat buildings or generate electricity. So it is a natural part of the energy flow within the earth's depth. Now, most of the commercial grade production geothermal energy is harvested along localized geothermal systems where the heat flow is near enough to the surface that hot water or steam is able to rise either to the surface or to depth that we can reach by drilling. Next, we come to the tidal power, which is also very important, but everywhere we can't use tidal power to generate the electricity. So, tidal power or tidal energy is a form of hydro power that converts the actually the tidal tides which is coming into the sea and anywhere the it contains a large amount of energy. So when it comes to the turbine blades, this energy is converted into the mechanical energy, and turbine is connected to the generator which convert its mechanical energy into the electrical energy. So, tidal power or tidal energy is a form of hydropower that converts the energy obtained from tidal into useful form of power, mainly electricity. So, tidals are more predictable than the wind and the sun. Okay. So, we will discuss it in detail how tidal power plants works and what is the complete procedure to generate electricity from the tidal power plants. So, tides are more predictable than the wind and the sun. Among sources of renewable energy source, tidal energy has traditionally suffered from relatively high cost and limited availability of sites with sufficiently high tidal ranges or flow of velocities, so constricting its total availability. Now, this is a simple layout of tidal energy that this is your sea. When tides came, it collide with the turbine. It turbine gets rotated, and this turbine is connected to the generator, which convert mechanical energy into the electrical energy. And when tides going out, then it is also converting its mechanical energy into the electrical energy. Next is your biomass energy. So biomass is organic material that comes from plants and animals, and it is a renewable source of energy. So biomass contains stored energy from the sun. Plants absorb the sun's energy in a process called photosynthesis. When biomass is burned, the chemical energy is biomass is released as a heat. So these are the sources of biomass. This is sewage, municipal solid waste, animal residuals, industrial residues, forestry crops residues, and agriculture crops and residues. So these are the big source of your biomass sources, biomass energy. Now, I think now you are able to understand easily what are the renewable and non-renewable energy sources. Now we comes to the MCQ. After going through this lecture, you are able to solve these questions very easily. So question number one: which of the following is non-renewable source of energy? So no, non-renewable source of energy is fossil fuels. We have already discussed. Second question is fuel used in thermal power plant is fossil fuel in the form of coal. Third is your in a hydropower plant, the potential energy possessed by stored water is converted into electrical energy. Kinetic energy possessed by stored water is converted into potential energy. Electricity is extracted from water. Water is converted into steam to produce electricity. No, potential energy processed by stored water is converted into electricity. Okay. Now, next one is your which is one is the ultimate source of energy. Which one of the following forms of energy leads to least environmental pollution in the process of its harnessing and utilization? So, environmental pollution is basically from the thermal energy. Next question is your ocean thermal energy is due to energy stored by waves in the ocean, temperature difference at different level in the ocean, pressure difference at different level in the ocean, tides arising out in the ocean. So this is basically from temperature difference at different level in the ocean. Now, the major problem in harnessing nuclear energy is to how we have already discussed it is very difficult to dispose of spent fuel safely because it is very harmful your human body. Now, the main constitute of biogas is methane. The second last question is the power generated in a windmill is more in rainy season, doesn't matter rain is coming or not, depends on the height of the tower, depends on wind velocity. It's depend on the wind velocity. If wind velocity is high, your generating power from the windmill will be also high. Last question is nuclear energy is derived by combustion of atoms of uranium 235. Obviously, we have already discussed that the fission procedure is used in nuclear power plants to generate energy but through the uranium 235. So this is all about your basics of renewable and non-renewable energy sources. Hope you will understand easily by this lecture that what are the energy sources which is present on the earth. So if you have any problem, you can ask me in the next lecture. Thank you.